We're starting with iron, reacting with oxygen in presence of moisture. This reaction happens. The result is rust. Rust is a powder. It doesn't have dimensional stability of iron. Total change of property. This is a chemical reaction. Breaking bonds, the bond between oxygen and oxygen are broken. New bonds form between oxygen and iron. So that's what a chemical reaction is all about. Let me go to the next slide. If you react magnesium oxide with carbon, it makes carbon monoxide and magnesium metal. So a chemical reaction may take 1 hour, it may take 5 days, it may take several years, and we may work on it for 5 years for somebody doing their PhD on a chemical reaction. The result of a chemical reaction is always, doesn't matter how long it has taken, it's always presented by a chemical equation. What's the chemical equation? What does it show? It shows where you started from and where you ended up with. So there is an arrow between left and right. What is the meaning of arrow? It says reactant reacted with each other. Arrow means to form products. So this means we started with carbon and magnesium oxide. This arrow means we started with reaction of carbon and magnesium oxide, and we ended up with carbon monoxide and magnesium. So this arrow means to form. Carbon and magnesium oxide reacted together to form carbon monoxide and magnesium. Okay, so if we are representing result of a research for 5 years or 10 years to investigate a chemical reaction, reactant and product, we are showing a chemical equation to summarize everything which happened. We also need to use some shorthand symbols in a chemical reaction. We use plus between two chemicals. It separates formulas. It separates reactants from each other. See, it separated reactants from each other. Can I also say that it separates products from each other as well? So plus means separation between substances and reactant or product. That's what we use plus in a chemical reaction. We use an arrow. It shows changes from reactant to product. It shows formation of products from reactants. Sometimes chemical reaction does not happen unless you use heat. So we use delta. And delta, you're familiar. If I say delta T, you need its change of temperature, right? So we use delta for change of temperature. That means this reaction is only going to happen in presence of heat. Another word, if I go back, if I write this here, it means these two reactants need heat to form these products. Without heat, this reaction is not going to happen. That's why we have delta above the arrow. That's what it means. That's the meaning of delta. What about phase of reactants and product? Well, you know matter has three phases: solid, liquid, and gas. Solid like ice, liquid like water, gas like steam. Showing the state of reactant helps to understand chemical equation. So if it is solid, we use S. If you're dealing with liquid, we use L. And if you're dealing with gas, we show G. And if you're dealing with something which is dissolved in water, with a solution, we show dissolved in aqueous, in water. For example, if you are using a reaction where you are using table salt in the crystallized solid form, this is the salt which is coming from your salt dispenser. And if you are using water at room temperature, you write it's liquid water, not solid, not gas. If you're using ice, then you write H2O S. And if you are using oxygen, you write gaseous oxygen because at room temperature is gas, if you are using at room temperature. And if you are using salt water, that means salt water. If you use salt water, that means you dissolve. That means you took the solid of sodium chloride. You dissolve this in water and you obtain salt water, you write NaCl. Can you guess what I should write here? Aqueous. So dissolving solid sodium chloride in water in liquid form is going to produce aqueous sodium chloride. Let me write this better so you can read it. So it results to the formation of aqueous sodium chloride. So do you see the difference between aqueous and liquid? Liquid is pure water. NaCl, aqueous means NaCl dissolved in water. Two different things.
Sorry, I didn't catch that. You can also try spelling it.
I'm sorry, Siri is interfering, trying to listen to our talks. I apologize for Siri to be an intrusion. Okay. Do you have any question, guys? Anybody? Anybody? Any questions? Okay. So, guys, in this chemical reaction, do you see there are coefficients here? These coefficients shows number of molecules that need to be reacting together to form number of molecules of product. And we will be using these in our calculation pretty soon. We will use this in mass calculation. So these numbers means, for example, here, 4 molecules of an H3 reacts with 5, right here, 5 molecules of oxygen. to produce 4 molecules of nitrogen monoxide and 6 molecules of water. Pretty soon I'm going to give you a concept which is called moles, which means large number of molecules. So you can also use moles instead of molecules. Moles are a large number of molecules. So you can say 4 moles of NH3 reacting with 5 moles of oxygen to produce 4 molecules of NO and 6, mole. 4 moles of NO and 6 moles of water. Are you here? Do you hear me?
We're with you.
Thank you, Cole. So in this reaction, we are reacting hydrogen, diatomic hydrogen, and chlorine to make hydrochloric acid, which is our stomach acid. In this process, if we use 2 grams of hydrogen and 71 grams of chlorine, they add up to be 73 grams of starting material, we are going to get 73 grams of product. So do you see these 2 masses are equal together? It means in a chemical reaction, mass remains the same. There is no matter created. There is nothing destroyed. What you end up with is what you start with. The mass remains constant. We don't have mass change in a chemical reaction. So that's one principle that we can use. In nuclear reactions, there is conversion of mass into energy. In a nuclear reaction, matter is converted to energy, there is change of mass. But in chemical reactions, there is no change of mass. Mass is conserved, and we call this law of conservation of mass. We will use this to calculate mass. For example, if I give you mass of the 2 reactants, this and this, ask you how much hydrochloric acid is going to be produced, you say, okay, reactants, I add masses together, I have mass of product. Simple concept. In a chemical reaction, atoms are not created, atoms are not destroyed. What do they do? What do atoms do in a chemical reaction? As I said before, they change partner. See? This bond is broken. This bond is broken. So these 2 bonds are broken. And then, do you see 2 new bonds are formed? That's all chemical reaction is about. So, if bond is broken and new bond is formed, atoms are not destroyed. They are not created. So matter remains the same. So mass remains the same. Do these make sense to you? So that's one of the principles we use in our chemical calculation. What you start with, you end up with as far as the mass is concerned.